Hi class. Let's turn our notes to 9-3 and take a look at this first problem. It says the purpose of this exercise is to determine whether triangle ABC can be constructed when two lengths A and B and the measure of an acute angle A are given. First, angle A and the side of length B are constructed. Let's go ahead and do that. So we're going to draw angle A. Here's angle A. And side length of B. So we'll call this side length B there. Finally, a circular arc is drawn with center C and radius A. We're going to put angle C right there, and it's going to have its radius of C be this side length of A, since we see A is opposite its actual angle A. Now what it means that when it says a circular arc is drawn, what we can imagine is that the A is like the radius of circle C. And so the arc that we're forming would look something like this, where kind of think of this A like a door or a hinge, where you're swinging this and you want to try and form a triangle out of it. Given that the distance from C to the opposite side is B sine A, determine which of the following conditions, whether 0, 1, or 2 triangles, can be formed. And so we see these 4 different possibilities. We'll go through each of them. But before we do, we just need to bring this back to what we had learned back in geometry with our trigonometry and geometry. Previously in geometry, you had learned that with triangles, typically you saw things where they gave you 3 different things. Maybe they gave you 2 sides and an included angle, so you would be dealing with something like SAS. Or maybe you were given all 3 sides and you were basically trying to form some unique triangles. All the different possibilities you've come up with were like SAS, SSS, you came up with ASA, angle side, AAS, even HL, because that was for right triangles. These were congruence theorems, triangle congruence theorems, were used to show unique triangles. Used to show unique triangles. And the thing about what we had learned was a big no-no in geometry was actually what we had just drawn. Notice how in our triangle, or sort of a triangle, we're going to create a triangle. We're developing something where we have an angle and 2 included sides. We're going to be given angle A, and then we know side B and side A. And you learn from geometry, you do not want to have profanity used on those triangles. So you had learned that we cannot use ASS, or maybe your teacher said don't use SSA. In either case, you had learned you couldn't use this because you would not be able to form unique triangles. And we're going to see why we don't get unique triangles in the case today. What we're going to look at is these 4 possibilities and see what develops from there. Okay? So what we're going to do is we're just going to go ahead and start with part A here and take a look at what's going on here. Now if you try and develop a triangle, again we'll draw it again, where we have angle A, and what we see here is that there's a side B and also a given side A. Now the thing about this is this A is less than B sine A. Where exactly is that B sine A coming from? Well, if you think about how a triangle typically needs to have a height right there, if you draw that height down, if you develop your trig function and say with angle A here, the height is given with opposite, and then we have B be the hypotenuse, we know that sine A is equal to opposite over hypotenuse. So in other words, we're saying that H is the same thing as B sine A. That's where the B sine A is coming from. So in other words, this question is basically asking us, what happens if A is less than the height of the triangle, the H value? Because that's what we just found right here. So if we find that A is less than the H, that's actually what we just drew here. Keep in mind that A is acting on a hinge at vertex C right there. So imagine that this A value, this hinge, is rotating all the way across here. And the problem is that this A is so short that by the time it swings over here, you want to form a triangle. It's reaching. It's trying to reach that other side that's way on the bottom. However, because it's too short, A can never be able to touch that third side. So if A is less than H, or in other words, A is less than B sine A, what we notice is that we can't actually form a triangle out of it. We get 0 triangles that are formed. That's what's happening in this first scenario here. If A is less than B sine A, we get that 0 triangles are formed. Okay? Let's keep going and examine what happens as we do the other scenarios here. So in our second scenario, we say that A is equal to B sine A. So in scenario B, let's draw this again, where we have angle A, we have side B, and again let's draw side A, but let's make it a little bit longer, because what's going to happen now is that as A is swinging, remember it's on a hinge, as A swings in that circular arc, what we'll notice is actually A is going to be able to represent the height of your triangle, because A is equal to B sine A. And we just saw from scenario A that B sine A is the same thing as the height of the triangle. So if A is able to swing, and because it's equal to H, it will basically it will touch just at that one point when you have H. It'll swing, and that side will actually end up coming right here. So what you end up seeing there is that if A is equal to H, or in other words, we said A is equal to B sine A, you notice that you form how many triangles? You form one right triangle. Because the only place it touches is when you get the height. Okay, so that's going to be our scenario 2, where that A value, it swings, and because A is a little bit longer, if it ends up becoming where A is actually the value of H, or B sine A, what you find out is that you end up getting one right triangle. Okay, so that's going to be scenario 2. In scenario 3, what we see is that B sine A is less than A is less than B. What does that mean? Well, let's draw that. Let's see what's going on there. Let's draw that angle A again. We'll have side B, and then again we're going to have this side A kind of come out. However, in this scenario, notice how if B sine A represents H, what we're saying is that A is greater than H. So we're actually making A pretty long. It's going to be long like this. Okay? And what we're going to do is, if we can say that this is the height, which is B sine A, then we're saying A is greater than H in this particular scenario, in scenario 3. So when that happens, when we swing A, notice now what we actually do is we're going to pass through this line. And when it passes at this particular point, that is when you can actually form your triangle. And as A swings, the thing is, it's going to swing, but also it does have a possibility of swinging and touching at this point too. And because it touches at this point, you can end up forming another triangle, because as A swings, remember it's like a door, it swings, this was also the side length of A. Which means you end up actually with two different triangles. When A is greater than B sine A, you might end up with two triangles. You might end up with a triangle that we drew in the first case, where A is like this. Here's B, here's A, and here's angle A. Or you might end up where, as it swings all the way across, you'll end up with an obtuse triangle like this, where here's angle A, now here's side A, and as it swung over, this is where it ends up on the left-hand side. Okay, on the left-hand side of the height. And then this would be like side B there. Okay, so you end up getting two triangles formed. Okay, now keep in mind that the other criteria was that a value also needs to be less than b. Because imagine if this a value is less than b, it's actually going to touch at this point along this ray here. However, if you end up seeing that the a value is greater than b, let's see what happens as we swing. Okay, so here's going to be scenario D. If a is greater than or even equal to b, as you have angle A here, angle A, here's side B, and if angle A is really big, but it's also, let's say, greater than or equal to b, let's make it equal to b and see what happens. If it's equal to b, then you're just going to have that one triangle, because if they're equal, then what you'll form is the congruent triangle. Okay? So as it swings, you'll form the one triangle here. However, as it swings, and if A is equal to B, because it's on a pivot, A is actually going to be at that exact location on B, and then, well, you'll actually not have a triangle anymore. You'll just have this line and then this line here, so you'll have just an angle. You won't have a triangle. If A is greater than B, let's say A is really long, then again you're going to form that triangle that is right here, let's say. But then what ends up happening if A is really long and it swings across, it's actually going to go past B because it's so long, and then you won't form a triangle anymore. What you'll form is, I guess, more like that, and that's not a triangle. So we can't have that scenario happening. Only the triangle that's formed is when A is over on the right-hand side. So if A is greater than or equal to B, you'll basically only have one triangle formed. Okay, so those are our different scenarios. So to recap, what we see here is if A is less than B sine A, or if A is less than the height, 0 triangles are formed. It just can't reach it, can't make it. You don't get a triangle. In scenario 2, if A is actually the same length as the height, if A is equal to B sine A, it's just going to touch at that one point, and you'll form a right triangle. In scenario 3, if A is greater than H, as you swing, because it's greater than the height, you'll form a triangle on the right-hand side, and as long as A is less than B, you'll also form a triangle on the left-hand side, making an obtuse triangle. If it's on the right-hand side, you'll get more of that acute triangle. Okay? And then if A is actually greater than or equal to B, you'll get the side length over on this side. You'll form that one triangle, maybe even an isosceles triangle. But if A is greater than B, it swings all the way over, and you're not going to be able to form a triangle. You just form this weird shape like that, like a Z. Okay? Alright, so let's go on to the next page. And you'll see a big blank space. What we're going to do is we're going to draw a triangle here. Pardon, I'm not using a ruler because I am on a tablet here. It's a little bit harder to use a ruler on a tablet. Okay, so I'll just draw my triangle looking like that. And just like we did in the previous page, what we're going to do is we're going to call this angle A. And I believe we called this angle C last time. So that should make this angle B then. And one thing that you learn in geometry is that opposite sides are basically the lowercase letters of its opposite angle. So this is going to be side A. Here we'll have side C. And over here we'll have side B. Okay. Now, a lot of you are itching to use this. What we're going to do is we're going to prove a particular law here. The idea here is that if we drop this dotted line down and form the height of a triangle, we talked about how we can find that height previously in a previous section. What we had said before was that if we take a look at the left-hand triangle and we compare it to angle A here, we know that the height and the B can give us a ratio by using sine. If we say sine of A is equal to the height, opposite, over the hypotenuse, which is B, we can say sine of A is equal to h over B. What we can also say is if we look at angle B, let's focus on B instead. B has height be its opposite side, and then the a value is also its hypotenuse. So we can also create another trig function where sine of b is equal to opposite, h, over hypotenuse, a. Well, if both of these trig functions have h's in them, what we can say is that h is the same thing as b sine a. In our other trig ratio here, we see that h is the same thing as a sine b. Well, if both of them are h's, that's basically a system of equations, where we can say that b sine a is equal to a sine b. Just set those h's equal to each other. If those are equal to each other, what we can do is just kind of group similar letters together. We can put all the a's together and put all the b's together. The way we do that is we can just divide by a on both sides, and then divide by b on both sides. And when you end up doing that, what you'll notice, let's bring it on up here actually, what we'll notice is that what we can create is sine a over side a is equal to sine b over side b. And as it turns out, you could also do the same thing with angle c. We won't do it just because I don't really have enough room, but the idea here is if you notice the pattern, you can say that's the same thing as sine of angle c over side c. And this right here is what we call the law of sines, because it deals with sines. Because this is a proportion, I guess you could also rewrite it a different way. Instead of saying sine a over a, you could also say a over sine a, which is equal to b over sine b, which is equal to c over sine c. It doesn't really matter since you're just dealing with proportions. This is basically used when you want to find different parts of a triangle, and you don't necessarily need the height anymore to then be able to find those missing parts of the triangle. Okay, so let's go ahead and apply all the things that we've talked about so far. How we can form different kinds of triangles, because we may not end up with unique triangles, along with this idea of law of sines, to then find the angles and sides of a particular triangle. Okay, so here we have triangle ABC. If angle B is 36 degrees, A is 10, and B is 8. What we want to do is find the angles and sides. Now, when you end up doing this, because they give you this information, notice how they give you an angle. They give you two sides. Oh, look at that. Uh-oh, ASS. When they give you this, what this is telling you is that you may not have a unique triangle. And because you don't have a unique triangle, there is the possibility, as we saw before, of maybe having 0 triangles, maybe having 1 triangle, maybe 2 triangles, maybe it's a right triangle, or maybe it's just some other kind of triangle, like maybe isosceles. Okay, so that's our job to figure out. What kind of triangle is this dealing with? So as we take a look at number 2, the first thing to do, it would be helpful to draw a picture. Let's go ahead and draw what we've been accustomed to doing on the previous page. To draw this, you always want to start off by putting the given angle in the left-hand corner. Given angle on left side. Okay? So because angle B is 36 degrees, I'm going to go ahead and put B right there. It's given to me. That's where I'm going to put my 36 degrees. From there, I can label all the other parts. Because I notice that I also have a side length of B, which is equal to 8, I know that the B's are opposite each other, so this B is going to equal 8. And so therefore, my A equals 10, that must be this side here. Because that way we'll actually form that ASS, the angle, the side, and the other side. That means that if this is A, then what we'll see is that this must be angle A, and so this must be angle C then, and then this is side C. And we want to find all the missing parts here, so let's just go ahead and get started. First thing to do, before you do anything, you need to make sure that you figure out what kind of triangles you're dealing with. You don't just have one unique triangle. There could possibly be other kinds of triangles. So the first thing to do is to find the height. First, find the height. This is what you always want to do when working with non-right triangles. Always find the height. So let's go ahead and find the height here. Okay, so to find the height, I'm going to go ahead and drop a dotted line here. That's going to be our height. Okay, and so what we're accustomed to seeing is that if we want to find the height, we know that with 36 degrees, we have opposite over hypotenuse. So sine of 36 is equal to h over the hypotenuse being 10. That must mean that the height is equal to 10 sine 36 degrees. Okay, so let's go ahead and calculate what that height is. I'm going to pull out our calculator. Go ahead and get your calculator out as well. And we're going to do 10 sine of 36 degrees. And we get a height of 877 or 5.88. I'm going to go ahead and store this as A, just so I can use that number later on. Okay, so our h value is 5.88 basically, but I remember that that's going to be stored as my a value in my calculator. Now, because that's 5.88, notice what happens. If we write here, I'm going to go ahead and make this a little bit bolder so you can see it. Let's do this. 5.88. Because that's our height right there, notice how the side length is 8. Look at that. That 8 is extra long. 8 is going to go past 5.88. So that means you're going to form a triangle in this location. And as 8 swings, notice how 8 is also, well, it's less than 10, which means it's also going to touch the side length right there, which means you're going to form those two triangles that we see there. You're going to form the first one that we drew, which was this triangle, and then as that side length of B swings around, because that 5.88 is less than 8, but the 8 is less than 10, you are going to form two triangles. Okay, and because you have two triangles, you got the acute angle here, but what you'll also form is going to be that obtuse triangle like this. Okay, so you have these two triangles that we need to then find the angles and sides of. Oh, that makes it extra complicated. Okay, so let's go ahead and do that. Let's first work with figuring out what that angle is that we're forming at angle A. And the way we do that is, well, I guess we can use our trig ratio, right? We know that if here's angle A, notice how we did find the height, which was 5.88. And if this is angle A, if you just take a look at this triangle here, then we can use 5.88, that's the opposite of angle A, and we can also use the 8, that's going to be the hypotenuse of this given triangle here. So what we can say then is sine of A is equal to opposite, 5.88, over hypotenuse, which is 8. And then, therefore, if I need to find angle A, I can just do the arc sine of this value here. Okay, so let's go ahead and do that. So we do arc sine of, I can just use my answer, so alpha A from before, and then that's my 5.88, and then I'm going to divide that by 8, and then I'm going to get 47.28 degrees. My calculator is already in degree mode, so I got 47.28 degrees. So that tells me, let me write this in a thinner ink, that angle A is then 47.28 is, I believe what we said, 47.28 degrees. Okay, so keep in mind that because our trig ratio right there, remember, whenever we see this, you draw your unit circle and say which quadrants you're in. Because it's positive, we've got quadrant 1 and quadrant 2. So 47.28 must represent this angle here. That's our acute angle. That must mean that it's for this particular triangle, where now angle A is 47.28 degrees. Okay, so we know that this is 47.28. We know that this angle here was 36. What else do we know? We know this side length is 10. We know this side length is 8. And is that it? I think that's all we know, huh? So from here, well, I guess why don't we just finish this particular triangle off? If we know that A is 10 and B is 8, let's go ahead and find C. We need to find angle C, and we need to find side C. Well, if a triangle is made up of 180 degrees, that must mean that angle C is equal to 180 minus, what do we got? 36 plus 47.28 degrees. Okay, let's go ahead and do that. So we do 180 minus, what do we say? 36, I believe, plus that given answer, so second answer. Like that. And we get 96.715. So that's going to be our angle C. Let's just call it 96.72 degrees. And that way it adds up to a nice 180 degrees. Since 0.72 and 0.28, that's going to give us a nice whole number there. And then we now need to find side C. So to find side C, oh look, we actually just talked about the law of sines, where if you're given some angle measures, or maybe given some side measures, you can find whatever you're missing. And that's what we're going to use here. If we want to find side C, we can put that over sine of what angle C was, which was 96.72 degrees. And we're going to make that equal to something else. I'm just going to go ahead and use the 8 and 36 since that was given to us. That just makes it a whole lot easier to solve, I think. It's less complicated, less room for error. So we're going to do 8 over sine of 36 degrees because that represents side B over sine of angle B. So 8 over sine 36. That just means that if I want to solve for C, I just need to multiply both sides by sine of 96.72. So let's go ahead and do that. 8 over sine 36. 8 divided by sine of 36. And then we're going to close that off. And we said we need to multiply that by, what was it? I believe it was sine of that particular angle. So sine of 96.72. So let's multiply this by sine of, well, it's up above. I'm just going to do second answer there. Then we get side C is a length of 13.52, basically. Okay, so let's go ahead and say that C is a length of 13.52. Like that. Okay. All right, let's go on to, well, keep in mind, that was only the acute triangle. We need to now go on to the obtuse angle for angle A. So keep in mind that if we have 47.28, that must mean that this quadrant 2 also has a reference angle of 47.28. So you guys know what to do. If you want to find the actual angle, then angle A must be 180 minus 47.28. Okay? 180 minus 47.28 is going to give us 132.72. Okay, so now angle A is a measurement of 132.72 degrees. This is for our second triangle. We just repeat the procedure now. We just need to find angle C and side C again. So just like last time, we know that a triangle is made up of 180 degrees. So angle C must be 180 minus, we know that angle B was a given 36 degrees. And we also know that now angle A is 132.72 degrees. So let's just enter that into our calculator. So we're going to do 180 minus 36 plus 132.72. So 11.28 degrees will be our angle C. Wow, pretty small angle. Which makes sense. Look at how small this angle is right there. So angle C is 11.28 degrees. All right, now we need to find side C. Let's do the same thing. Let's do our law of sines. Side C is going to be over sine of angle C, 11.28 degrees. And that's going to equal, let's do the same thing, 8 over sine 36. It's okay to be consistent there. And then solve for C. Okay, so we have 8 divided by sine 36. And we're going to multiply that by sine of 11.28. And we get that side C is 2.66. And there we go. We have found our angles and sides of our two unique or different triangles. Okay, so that concludes number 2. I didn't leave a whole lot of room for number 3, but actually I don't think we'll need that much room. Let's see if we can fit number 3 right here. Okay, so let's have triangle ABC again. Let's do A. Cosine of A is 1/2. A is 6. Let's go ahead and put angle B here and angle C there. That means that if A is 6, that's going to be this part here. A is 6. It also tells us that cosine of A is 1/2. It's giving us a ratio. Well, I guess we can use that ratio, and we know that if we have a height of a triangle, and if the trig ratio of cosine is adjacent over hypotenuse, that would mean that this would have a side length of 1, that's adjacent, and then the 2 would be our other side here, where the C value is going to be a length of 2. So if we use this information, we can go ahead and find H. If you know your properties of a triangle here, I guess you can know what H is, but if you don't, that's okay. We can just use our Pythagorean theorem. We can say 1 squared plus H squared is equal to 2 squared. And therefore, H squared is what? 4 minus 1. H is then going to be square root of 3. And you might say, aha, I remember that. We go to square root 3, 1, and 2. That makes sense on that particular triangle. Okay, so what we want to do is actually find the length of B. That's what the question is asking us for. However, the length of B is not just that little side length of 1. It's 1 and something else. B is 1 plus, I don't know, let's actually call it something like x. So we need to actually find what that x value is. So let's just look at this right triangle now. Let me draw that in another color you can see. Let's look at this right triangle. And if you take a look, we are actually given its 3 different side lengths. We know that we have, using Pythagorean theorem, x squared plus root 3 squared is equal to 6 squared. And so if we solve for x is going to equal 36 minus 3, and the square root of that is what we'll get for x. So x will be the square root of 33. Which means if this is root 33, then now we have the side length of b, this entire thing. That must mean that b is equal to square root 33 plus that 1 that we got earlier. Okay? Alright, so that concludes our notes for today. You can go ahead and start your classwork/homework. Again, as I said on Monday, I think it would be wise if you actually did the even problems first, so you have your group mates to help you out and just check answers with. And then you can just do the odds for homework. Alright, well, have a good rest of the day.